Hi there, and welcome back to another Papetti Math YouTube video tutorial, where today I am going to be teaching you, yes you, Algebra 1. And in this video, we're going to begin our study on Chapter 9, where we start to look at how we can explore quadratics. In Chapters 7 and 8, you were introduced to polynomial expressions and different mathematical operations you could perform on those polynomials. But now in Chapter 9, we're going to be associating those polynomials with graphs of those functions. So it says it is important to realize what exactly you will be studying in this chapter. You'll be embarking on an in-depth exploration of a unique kind of function that has a wide variety of uses. Quadratic functions are one of the equations responsible for rockets being able to reach outer space. Wait a second. That means, yes, you are about to study rocket science. Another practical use of quadratic functions involves arrows, missiles, catapults, and any other projectiles such as footballs, baseballs, rocks, etc. While we are studying these functions on Earth, we know that whatever is thrown up in the air must come back down to Earth. This is because of the Earth's gravitational force. Since gravity is predictable, a quadratic function could tell you the projectile's position at any time it is in the air. So using these functions, we could tell a whole bunch of information about an equation, relating it to a real-life scenario of something just being thrown up in the air. Pretty interesting stuff. We're going to get more into this, but first, everything you have studied in chapters 7 and 8 have led up to this moment right here. You will now use your knowledge of polynomials and factoring to not only simplify, but also solve a quadratic. So a quadratic function is a polynomial with a degree of 2, which means the highest exponent is 2, or an equation in the form of f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. So our first exercise right here, we want to explain why a is not able to be equal to 0. And if we're looking, it says ax squared plus bx plus c, and a, b, and c are real numbers, but b and c can be 0. That's okay. It doesn't say that they can't. But why can a not be equal to 0? Well, let's take a look at f of x equals ax squared plus bx plus c. And let's see what happens when I take that a and I replace it with a 0. So I'm going to put a 0 here. We have 0x squared plus bx plus c. So if I were to simplify this, I'd get f of x is equal to, well, 0 times x squared is 0, so I don't need the 0 there, so I'm left with just bx plus c if I put a 0 in for a. So this looks an awful lot like mx plus b, doesn't it? Bx plus c. So because it looks like this, if we make a equal to 0, this becomes a linear equation. And we're not talking about linear equations anymore. We're talking about quadratics. So in order for it to be quadratic, you have to have a number before the x squared. The coefficient of x squared has to be a number, anything. It could be literally anything except 0, because 0 makes it a linear function, not a quadratic. Now, if this video was helpful in explaining why a cannot be 0 and just having an introduction of what we're going to be doing in this chapter, please give this video a thumbs up. And now you're ready to go on to exercise number 2. Thank you for watching.